Okay, let's continue writing here. Well, obviously our last lesson didn't pass the audio test. A bit awkward, but it's fine. It's fine. We'll fix it right away. Because we didn't clean up the leftovers properly. Sorry about that. That was overconfident. Sometimes you just get too confident, but you know how it should be written, and in your mind you deliberately left a gap there and made a mistake. Okay, alright. Now that the environment is set up, let's continue writing the rest of the code. Okay, here we'll start creating our country flow. We'll place this here. We'll use the source code to explain to everyone, so everyone knows how this thing is made. First, let's go back to our subtest, and then actually let's give it a method here. That way it's easier for us to test. Here. So this is essentially a level initialization flow for us. For example, right here, we'll call it while init my work. It should be called init user. Let's look at init level. Level initialization. We won't pass any parameters for now. No parameters passed. We'll pass parameters later. Then we'll create a UFunction here. Okay, actually, it's better to give a boolean here. Why give a boolean here? To prevent you from triggering this multiple times. To be honest, we can give a boolean. It's best to use an enum here, but we didn't write it that rigorously. Let's call it be in leading, that is, whether it is currently in the initialization process. Obviously, it is not in the initialization process now, so we put this be in leading here. We set it to true from the very beginning. Obviously here, if we are already in initialization here, and this method is called again, then it is obviously unreasonable. We will just let it return here. Actually, you need to make some judgments here. Let's first print a log. Print a log to tell our developers. Log temp. Okay, then we truly enter our initialization phase like this. So how do we create this control flow? Actually, it's very simple. We'll do it like this here. We'll go through this place again. We need to include the header file. As for this header file, including it here is sufficient. Include these two. Where does this common file come from? Actually, you just click into it. We mainly look at this. This is placed inside the ControlFlow manager. There are some methods here for creating ControlFlow. We need to use it. And then another thing is ControlFlow itself as an object. This struct, this declared object, and our method. You can see it is a ControlFlow created through this static method. Then it passes two parameters. The first parameter is object. That is, who holds it. The second is its name. Then please pay attention. That is this flow. It is attached to this eta, and only one can exist at a time. That is to say, all flows, they should all have this unique ID. If you want to do this with multiple, if this object has multiple instances, then you might encounter this problem. Because our flow is all one flow, and if you attach multiple flows to one iter, this doesn't seem to fit our design philosophy. Then you can use this make shared control flow to do it, instead of using this static method to do it. So if you want to do it this way, then how should you do it? You should use this part. You can see here it has a constructor, then the places make share. Need to pass this one. It is during initialization. That is, this is not passed. During the initialization process, it will make share one by itself. After make share, it adds tasks here, then executes in a loop, then listens to these. So that is how it is done. Okay, then let's go back here. Then we create and look at this flow. Actually, this place is a chain programming style, because you will find that it needs to return here. It's a reference like this. Right, it's a reference like this. Then we can click directly here. Just click directly here. For example, let's click here. What do we click? We click this pre-step. After clicking, you'll see what the purpose of this questive is. It also returns. It's actually a kind of chain programming mindset. Then we can, in the questive, Okay, right. And then in this task flow, we add something to it. We write it like this. Write a bit early, so we won't use chain programming for everyone here. Because if we use chain programming, it might be a bit uncomfortable for everyone to look at, in my personal opinion. But in Slate, we have to use chain programming. Then after creating a task flow here, we add tasks, and we add them in this way. For example, the first one we add local assets. For example, we do some asynchronous asset loading. Then we need to pass the name of this node here. The first parameter is the node name. We'll use this one here, because we've already written it. Then the second parameter. The second parameter is pass a z. Then the third parameter, we need to pass this method. As you can see, this method, its signature is actually like this. Let's write it here. Protect it. Okay, and it must have this parameter. Why is it like this? Actually, let's put this here for now. We need to wrap a function pointer like this. We need to paste this here. Okay, this way we initialize a task flow. The reason it is like this is because we need to look at the comment above. You will find this kill step. What does it do? It stores this user object, or stores a pointer like this. This kind of object is very useful. Then during counterflow, it will automatically deduce if it is a queue function, queue wait, or queue counterflow, or flow batch. These are some nodes that control the task flow according to this function signature. Obviously, the function signature here is this, CleanControlFlow. Then through this function signature, we can control the success or failure of this task node. Currently, we just need to take a look at it here and directly set it to continue. That is, we consider it as a success now. It could also be cancelled just now. Let me zoom in a bit. Cancel means it has failed or been cancelled. We generally just use continue. Okay, this way it will successfully proceed to the next step. We need a place to write a comment. Write a comment. If we write a comment, let's call it init local essence. Then we continue adding some new nodes. I'll just write something here casually. Let's leave it like this for now. We'll keep adding this information. Let's just write 4. Not too many, not too few. This init info, init year info, and finally notify the main UI. Then we recycle resources. Then we write the corresponding methods. Oh, just paste it here. Let me take a look. Then this function signature, let's keep it once. It's fine if you don't do it once. We need to rewrite this part, counter 4. We don't call it this way, it's a bit strange. We call it follows this init. Complete this initialization. Now we need to create the corresponding nodes. Then later we'll organize these methods first. Then we start creating like this. Because our network is still behind, so it seems we haven't given everyone no way to write a varied tool that is combined with the network to write. We write that for you when we have the chance later. Then everyone will need the network later. Write and modify it yourself. This demo is also completely fine. Okay, good. We can batch create them like this in this chapter. Then we create a declaration like this. Okay, it has been created. Then we just paste it directly. Let's put it here. Paste it here. Okay, and this part is a reference. Okay, after we finish creating this part, we print a log. We'll say begin has started. That means we are creating it. Or we put it here. We put it here. We call it init flow. Okay. Second, here we start executing. We start exact flow. Then we just let it execute directly here. Okay. After it is created, it will put itself in. You can see, yes, there is a found here. It should actually put it into a place. Okay, we'll just ignore it for now. Yes, in our previous version, we essentially saved this smart pointer. We can either save it or not. We can choose not to save it for now. Why not save it? Actually, we did it this way before. We did it this way before because it inherits from and seared from this. We can make it and seared. We can get its pointer like this. Then we can hold on to it. Yes, if we might. There is some other information here. When we need to query it, we might find it necessary to hold this pointer. But there is no need for it at the moment. You see this place, it will look for it. It will say whether this kind of repetition is allowed. If it is repeated, this place will perform a reset or some other operation. If we don't have it here, if it is not found, this place is clear internal. Internal will have a false transfer. If here you can see this place has no share, you see it was created. Right after creation, it depends on whether it is persistent. If it appears, it will be placed into this container. You can see that this is a TWE8ATA container. This is a static one, and if it doesn't appear, it will be placed into this container. It just holds onto it like this. Okay. Then this part is where it manages its own lifecycle operations. Alright, we won't follow it anymore. Okay, because when it is actually used, it will tick in the main thread within the tick function. Look at this method for handling the flow. Then we are pretty much done with these. Then over here, this file has actually finished executing. Yes, okay, let's start it up. Let's test this process to see if it works. There's an error, right? Let's check it. The reason for the error is this. Let's see what this struct is. It's a smart pointer. Let's try to make a forward declaration. See if it works. We don't really want to include it here. This place. If it still doesn't work, we can see where it is located. It is located here. We need to include it. Okay, put it here. Redefined objects. Then move this part to the front. It cannot be included like this. Wait a moment. Cut it out and bring it over. Then here, put it here. Okay, now let's start it up. Let's see if this process has finished. Good. Now let's execute it. Right here, let's just use one to execute. Then we get our counterflow subsystem. We input xg. Okay, this should be it. Then we execute it. Compile here. Let's check if this method is exposed to blueprint. Maybe it wasn't written to be exposed to blueprint. This thing. Indeed, it wasn't written here. Let's add it. Close it yourself. Let's copy one from earlier. This discount is really hard to explain. Let's restart it. There is one more thing we need to write here. For this be-in lighting part. After it finishes executing here, we'll turn it into a force. Yes, like this. We should try to ensure it's a single process. Only one process is running at a time. Then after one process finishes, the next process can execute. Okay, then let's go to our observation chart. Now let's init level. We'll just check the log. Let's see if it's linked yet. Okay, no problem at all. Let's click again. Still no problem at all. This proves that writing it this way is fine. Then let's set a breakpoint because we haven't added this part of the process yet. So we're still quite happy. This breakpoint can't be hit, right? If it can't be hit, I'll restart it. This project might not have that viewpoint. Okay, we're restarting now. It's already brought the breakpoint in again. Next, what we need to do is we'll set breakpoints for everyone here because actually we can create a variable here to check which frame it is. But we'll just go through the breakpoint part after we come in. Actually, on our side, we can look for some global variables, but it's not easy for me to find this place. Anyway, there is one we haven't. Let's go to this. In the standalone program, I found a global variable for everyone. Okay, so let's go down here. Typing a word here at the beginning is fine. Then we created a control flow. Here, add these tasks in the control flow. Then we start executing here. Then execution starts here. After execution, we enter here. This is where the control flow is executed. We'll ignore it. This place. Note this. Equalize next model in Queen. Then we continue moving down. This place has entered. Here we can see it's executing this process. See, let's observe again. This place process. Okay, so this is actually a proxy. You see, this flowed. Actually, this node is the one we created. Actually, the quiz table comes in. Then let's look at the continuation flow. Hey, it reaches this point. But actually, a lot has happened at this point. You can see this whole chain of things. Then actually, if we click this Ctrl4 now, we can go inside. And here, this place just doesn't look good. This is his place here. This count 4. Let's go in again. Once handle counter 4 complete is done, it's finished. So obviously it must also have one here. Hey, Azay's Lexus Nord in Queen. Doesn't this look familiar? This excuse. Okay, then keep going. This place. Hey. Got in. Hey, you will find. Actually, right now we are all on one frame. The first frame we explained to him is A, B, C, D. This is how it looks now. This is also completely fine. We have now placed all tasks on the mainline layer. That means these 5 tasks all need to be completed in this one frame to be done. Okay? We have essentially finished this part. Move it over, then it's done. And then in our life cycle, we actually don't need to worry about it anymore because we haven't done anything to hold its life cycle. So we don't really need to worry about releasing or anything. The only thing we consider about the life cycle is this blet, because in this initialization process, there may be more than one bool. There may be many struct info. So later on, that is before this process starts, you need to clear it once. After the process ends, you need to recycle it. That's roughly the idea. Okay, that's all for this lesson. So here we are. We have built the most basic framework of ControlFlow. It will proceed step by step. Okay, then that's all for this lesson.